people are still trickling in, but they will catch up. Um, so thank you for joining us for the University of Minnesota Climate Adaptation Partnership's noon webinar today. The topic of discussion today is resilient farm planning, tools for changing conditions. My name is Katie Black. I'm an extension educator with the University of Minnesota Climate Adaptation Partnership, and I focus on supporting resilience within the agricultural sector. We're going to begin with just a brief bit of housekeeping. On the bottom of your screen, or the top of your screen, you'll see a toolbar with a number of icons. In the middle of that screen where you see the green button, right to the left of that, you'll see a chat button where you can chat with the webinar organizers to get help if you're having technology problems. To the right of that green button, you can see the Q&A feature. That's where we ask that you can submit questions and upvote others' questions via the Q&A feature if someone asks something that you're very interested in learning more about. There's the raise hand icon that's indicated by the hand, in which you can raise your hand to ask a question directly, although we do ask that you hold questions until the end of the presentation. And then finally, this webinar will be recorded. Lauren, you can go ahead and start recording.
We're recording.
Thanks, Lauren. All right, so you're with me for the next 45 minutes to an hour, and I wanted to give people an overview of what to expect. So today we're going to talk about changes to Minnesota's weather and climate patterns and what it means for agriculture, primarily row crop agriculture. We'll talk about the relationship between long-term planning in agriculture. We will take a look at our new Resilient Farm Planner tool and walk through and describe some of the features of that tool. We'll wrap up with some additional resources and learning opportunities with MCAP, and we will have time at the end for questions. Some of you may be familiar with the University of Minnesota Climate Adaptation Partnership, but some of you may not. So I wanted to give a brief overview about who we are and what we do. The University of Minnesota Climate Adaptation Partnership, or MCAP, as I'll refer to it from here on out, is a group within the University of Minnesota that is co-located between the university's research branch and extension branch, which is unique to other groups within the university. We have both scientists and educators on staff. So that means that not only do we conduct cutting-edge research, but we also develop educational programming to bring that research out into the public. We focus on adaptation, otherwise known as taking action to prepare for and adjust to the current and projected impacts from a changing climate. We'll talk a little bit about our approach to problems. Ultimately, we are future-focused. We have sectoral expertise ranging from the built environment to tribal resources to healthcare and more. We provide research-based education and technical assistance to our partners, and we partner across a wide variety of sectors and scales. This is just a few of our partners that we have been fortunate enough to work with over the past couple of years. If you see yourself on this list, thank you for your partnership. And I just wanted to reiterate that we are again focused on adaptation. So often when we're talking about changing climate and weather patterns, you might hear the terms mitigation and adaptation, but I wanted to define those for the sake of this presentation. So adaptation is again focused on preventing the impacts of climate change. And preparing for, adaptation is focused on preparing for the impacts of climate change, whereas mitigation is about preventing climate change, preventing worsening impacts. There are a number of ways the agricultural sector can contribute to mitigation, preventing changes to our climate. But again, for the purpose of today's talk, we are focused on adaptation. We're gonna launch now into talking about observed changes to Minnesota's weather and climate patterns. And as I'm talking through this information, I invite you to think about experiences you have had that indicate to you that Minnesota's climate is changing. We may be able to corroborate some of those experiences with our observations across the state. So we know that Minnesota's climate is already warming. This is data from the DNR. In fact, average annual temperature across the state has increased by about 3 degrees since 1895. But the thing to note is that that increase hasn't been consistent by location or time of year. This slide is a little busy, so let's break it down. We're looking at observed temperature change since 1895 across the whole state of Minnesota for the average annual on the left, the winter lows in the middle, and the summer highs on the right. It also divides the state into north, central, and south. The main takeaway that we're hoping you'll observe is that the warming we've experienced hasn't been consistent across location or season, with our most dramatic warming occurring in the northern portions of the state and during winter, thus far due to a phenomenon called Arctic amplification. That warming already has implications for agriculture. The growing season has increased, for example. So this is a graph showing the change in growing season length, otherwise known as the freeze-free season length, between 1970 and 2023. You'll note that in Minnesota, we've observed an increase of more than 2 additional weeks in the growing season over that time period. We've also observed that Minnesota's climate is getting wetter. This is again data from the DNR. We're looking at precipitation for the entire state of Minnesota annually, over the 1895 to 2024 time period. One thing to note is that you might notice the wiggles from year to year, right? We see changes from year to year. That's a normal part of our climate patterns. However, you can also see that there is a very clear trend line from that data. Thanks to that trend line, we've been able to determine that average annual precipitation has increased by about 2.8 inches on average between 1895 and 2023. We've also seen that extreme events are becoming more frequent. So this, again, is data from the DNR, but this beautiful graphic has been made by Minnesota Public Radio. This is a timeline of Minnesota's historic mega rain events from the mid-1860s to 2014. You might be asking yourself, what is a mega rain? It's when 6 inches of rain covers more than 1,000 square miles in 24 hours or less, with at least 8 inches falling somewhere in that area. It's a bit hard to visualize what that looks like if you haven't experienced, but if you were out standing outside during that time period, you might describe the experience as biblical. So let's take a look at what's been happening over that time period. From the mid-1860s to the mid-1960s, we've seen 4 of those mega rains in 100 years. From the mid-1960s to the late 1990s, we saw 3 of those in 33 years. And in just 2000 to 2014, we saw 5 of those mega rain events in just 14 years. So we see that the magnitude of those wet extremes is increasing. There has been additional research that has shown that the magnitude of wet extremes thus far have increased more than dry extremes like extreme drought, and that the transitions between dry and wet periods have accelerated. I think anybody can think back to the last couple of years we've experienced here in Minnesota to think about how that plays out on the landscape. And finally, we can see trends occurring when we combine both precipitation and a temperature. Again, this is a little bit busy of a graphic, so I'll walk you through it. We're looking at warmth and wetness compared to the 20th century. The blue dots represent all years between 1895 and 2024, and the red dots represent the combined wettest and warmest years on record. So on our x-axis, we can see that we are looking at degrees above or below the 20th century average. On the y-axis, we're looking at inches above or below our 20th century average. Over the last 30 years, we've noticed that a number of our combined warmest and wettest years on record have occurred after the 20th century. So, based on all this information, you might be asking yourself, what does the future hold for Minnesota's climate? We project that the effects of climate change on Minnesota will result in our state's climate becoming warmer, wetter, and more extreme. You might be asking yourself at this point how we know that. And the answer is that we're able to do that through the use of climate models. We only have time for a brief overview of climate models today, but if folks really want to deep dive into how these work, we have time for that at the end of this discussion where we'll share some additional resources. So, simply put, global climate models use established mathematical and physical equations to represent the Earth as an integrated system. They simulate the physics, chemistry, and biology of the entire Earth. The principles behind climate models are similar to what we use in terms of short-term forecasting to get weekly or monthly outlooks. And what they are fundamentally doing is looking at how these systems change in response to different levels of carbon or greenhouse gases in our atmosphere. The other thing to know about climate models and future climate data is that we have to use scenarios to understand potential futures. Although scientists know quite a bit about how Earth systems work, we do not know how society will act in the future, and we don't know which actions we'll take to either increase or reduce our greenhouse gas emissions, which has implications for changes to our climate. So we use these scenarios to show a range of what can be expected. On the left-hand side of this graph, you'll know that these scenarios, which are represented by different colored lines, represent different amounts of carbon dioxide in our atmosphere, or excuse me, carbon dioxide emissions. On the right-hand side of that graphic, we're looking at what those carbon dioxide emission scenarios actually mean in terms of expected degrees change. So for the sake of this presentation, we'll be largely focused on the scenario that it is represented by that red line at the top of both of those images. That is our very high emission scenario and can be thought of as an upper bound as to what as to what we might expect for our future climate. But I'll note that lower emission scenarios, which I've highlighted in green, are also possible. So, how are we getting this data from these global climate models? How different will our future climate be? At MCAP, we've developed a tool that translates global climate models into local impacts, also known as downscaling. So, you can access this tool at the link below. Basically, it is a high resolution climate projections, which means that you can zoom into an area of the state as small as 2.5 miles, and you will be able to see future climate projections for that region of the state. In there, we have multiple future time periods, such as mid-century to the very end of the century. We have multiple emission scenarios, which I just referenced, and we also have numerous variables that you might be interested in looking at in terms of how they will behave in our future climate, such as precipitation, precipitation intensity, temperature in terms of averages, minimums, and maximums, and lake ice freeze out, implications for our lakes and our soils as well. So again, we're going back to the projected effects of climate change on Minnesota. So now that we know how we got this data, we can talk a little bit more about the nitty-gritty of these data. So we're expecting Minnesota to become warmer. Previously, we've seen those changes predominantly in winter, but in the future, we expect to see warmer across all seasons and particularly warming in summer, which we haven't observed. We also expect to see our climate become wetter. So, wetter in spring, fall, and winter, but unfortunately drier in summers when we might want to see additional precipitation on the landscape. And as I mentioned earlier, we expect to see more dramatic swings between wet and dry events and more extreme events occurring. So I went to our tool and pulled out some data so we can again get more into the specifics of how much change we're talking about. So let's take a look at precipitation first. Again, think of what I'm showing you right now as an upper bound in terms of what is expected to occur by the mid-century, so 2040 to 2059. This data is looking at the difference between historic data and the 2040 to 2059 timeline, and we're looking at changes in precipitation. So the first thing you might note is that we can see trends, but precipitation is relatively variable across the state. We don't see one solid color across the entire state, for example. So let's take a look at the changes we might expect when we take a more regional view of the data. So when we look in the northwest corner of the state, we expect to see an additional 1/10 of an inch average increase over that time period. But when we look at the east central region of the state, we expect to see about an inch average increase by that time period. Let's take a look at the other end of the spectrum, from future precipitation increases to future precipitation decreases. Again, you can see perhaps some trends emerging from this image, but let's specifically take a look at what we're seeing when we pull out specific numbers. So when we look at the southwest corner of the state, we can see about a 1/2 an inch average decrease over that time period. But when we look at the southeast corner of the state, we see an average 1.5 inch decrease by that time period. And you might be thinking to yourself, an inch and a half, is that really a big deal? What does that really mean? Well, there are two things to keep in mind. One is that change will become more dramatic over time. So impacts we see by the 2040s to 20, excuse me, impacts we see by the 2040 to 2060 time period may be less severe than those we see by the end of the century, for example. The other thing to keep in mind, which I'm using this graph to demonstrate, is that averages or particularly wet years or particularly dry seasons can be made with changes of about an inch or so if we take a look at this graph, you might remember that May of 2024 was a particularly wet season. This is looking at that monthly precipitation versus our seasonal normals over 5 different locations. So the thing that I would like for you to pay attention to is that red trend line. That's what we would expect to see over that time period in a normal season. And one thing you'll note is that even though that time period stood out as being particularly wet or difficult to manage, in places like Duluth and International Falls, we saw, an inch and a half increases. So again, it doesn't take multiple inches, many, many inches of rain to have impacts on the landscape. So let's talk a little bit about what those precipitation changes actually mean for those of us who work in agriculture. So if we think back to wet springs, we are likely to see an inability to get into the field and further reduced work days in the future. Um, Erosion and runoff become a concern from those large rainstorms and additional precipitation. I'd also mention that we expect to see, more ponding, flooded out fields, perhaps prevent plant as a result. Again, because of that ponding and really wet soils, poor establishment and breeding issues are possible consequences. And just to add a little bit about animal agriculture, what very wet pastures can contribute to additional stress and disease in livestock. If we take a look at dry summers, this is a graphic I pulled for the drought monitor on the top of your screen of the state of Minnesota. It's showing you the drought monitor from July 20th of 2021. People will likely remember that that was a dramatically dry summer. And so the things I mentioned as potential future consequences may not be a surprise to you, but with a decrease in summer precipitation, we expect to see increased irrigation needs, perhaps development issues. Drought can impact the kernel rows in corn or the nitrogen fixation in soybean, depending on what stage of development that plant is at when drought occurs. And then we also expect to see increased weed control issues. Weeds like kochia and Russian thistle can develop a waxy coating that helps them outcompete other plants during drought. And we expect to see that problem emerge with weedier pastures becoming a problem due to those weeds outcompeting other species that may go dormant. So we've talked about precipitation. Let's take a look at changes to temperature. Again, we're talking about the same emission scenario, same timeline. So this graph is showing you the difference between what we've historically experienced and what we experience the 2040 to 2059 timeline. We're looking at the change in number of days that exceed 90 degrees Fahrenheit. So in the north central portion of the state, we expect to see on average an increase of about 10 additional days that are warmer than 90 degrees Fahrenheit. In the southern portion of the state, we expect to see increases of 25 days of days that are warmer than 90 degrees Fahrenheit. And you might intuitively know that that's a pretty dramatic increase for what we're used to experiencing in Minnesota. But I like to use this analogy just to, again, put things into context. So I'm using the 1930s as a point of reference that can set off some flags for people. I'm not using this to suggest that we're going back to the Dust Bowl. I merely use this time period as a reference because it was one of the most dramatic warm periods on record in the state of Minnesota. So from 1930 to 1936, Stearns County experienced an average of 27 days warmer than 90-degree Fahrenheit. Depending on the emission scenario that you're looking at, by the mid-century, we expect that Stearns County will be experiencing between 32 and 40 days. So again, quite a dramatic increase and perhaps more dramatic than things we have experienced in recent memory. I wanted to take a look, in addition to high temperatures, what happens to our low temperatures. So this graph is actually not very interesting because the trend is shockingly consistent across the entire state. This is looking at the difference between what we have historically experienced versus what we expect to experience in the 2040 to 2060 timeframe in regards to the number of days with a minimum temperature below 32 degrees Fahrenheit. So the loss of those cooler temperatures. Across the state, we expect to see about a 25-day average decrease during that time period. And so, what do those warming temperatures, again, mean for those of us who work in agriculture? Well, those higher 90-degree days, summers, those hotter summers, we can expect to see problems in terms of crop development. So on this graph that I pulled out on your right, this is data from a national climate assessment. This is looking at the optimum and failure temperatures for vegetative growth and reproduction in corn and soybeans. So I've called them out just to make it a little bit easier to read. So in corn, we see that the optimum growth is around 80 degrees, but that failure for reproduction can occur at around 95 degrees. In terms of soybean, we see that optimum growth is at 86 degrees Fahrenheit, and failure for reproduction happens at 102 degrees Fahrenheit. So again, we might see some uh, implications for crop reproduction, crop ability to grow when we're experiencing more of these very warm temperatures. These very warm temperatures can also interact with that decrease in precipitation that we are expected to see due to increased evapotranspiration, and that can result in flash drought occurring more frequently or more severely. We can see stress happening to people, plants, and animals under warmer temperatures. I don't think that's a surprise to anybody. And we also expect to see soil compaction issues again because those warmer temperatures can exacerbate those drier conditions. If we're thinking about warming temperatures year round, we obviously have to be aware of the increased risks of pests and pathogens that may be moving north or find themselves in Minnesota in suitable conditions than previously experienced. We know that warmer and wetter conditions is a breeding ground that pathogens traditionally like. We expect to see problems with the timing of fertilizer application. We may see people experiencing delays with applying their fertilizer because of warmer temperatures later into the fall season. And if we think about even winter, it's traditionally the off season in agriculture, but warming winter temperatures, in addition to creating potential opportunities for pests, can also result in some logistical difficulties. I know that my dad sometimes waits and holds off on transporting grain until winter. Um, if we're seeing more warm temperatures that perhaps result in decreased snow and increased rain, that can create problems for efficiently, effectively, timely manners of transporting your grain. And we also similarly expect to see implications for infrastructure in terms of how you're storing your grain. So, how does all of this information actually translate to planning for those of us who work in agriculture? I have this timeline to remind us of how we traditionally think of decision making and what tools we have access to. So, you'll note that this arrow bar is showing you a timeline of past, present, future decisions, and future in terms of very near term and very long term timelines. So if we need assistance with present conditions, we would likely turn to a resource like Endon, which is showing us daily or hourly information from weather stations. The MDA runoff risk forecast looks a little bit further out and helps farmers make decisions based on 72-hour forecasts. The Dawn dashboard, also known as the dashboard for agricultural water use and nutrient management, helps farmers make nutrient management and seed selection decisions with the ability of 6-month forecasts. But then there's a huge gap between those forecasts and what we are able to do with climate data, such as the data from MinClimate. So you might be asking, how is this climate data useful? I've grabbed this example. This was from a paper kind of talking about these issues with farmers in California who do tree crops. So the example that they used was looking at frost protection. So for a traditional weather forecast, you might be wondering what it means for frost. And that forecast would be able to tell you that the likelihood of frost for tomorrow is about 80%. So then it's quite easy to make a decision about whether or not you'll implement a frost protection measure tomorrow, like if you're going to put out the wind machines or apply some heat to those tree crops. Climate projections, if we're thinking about frost, can't tell us what your frost concerns might be most dramatic, what day frost might occur, but they can tell us the frequency that's required for large investments. So in this example, Of climate projection on frost, climate projection could tell us that we see a 50% decrease in the number of frost occurrences by March 2040. We can use that information to decide whether to switch to a different variety or whether to invest in new machinery based on those conditions becoming more frequent. Again, this is a pretty busy graphic, but I just threw this in the presentation to show people and remind people of the number of decisions that farmers have to make. This is showing you what timelines farmers typically make certain decisions on, what months they might make those decisions. But the big takeaway from this graph is that longer term practices or big investments such as rental contracts, cover crops, drain tile marketing, estate planning are decisions that are made on a 1 to 3 year timeline, a 3 to 5 year timeline, or a 5 to 20 year timeline. That, again, probably doesn't surprise anybody who works in agriculture, but again, has connections for how we can think about using this long-term data. And the other question that I get quite frequently is why do we need to make decisions about the future now? Again, we're thinking about the length of time it requires to make those decisions. Um, but we also know that building resilience takes time. Soil health practices are commonly recommended as practices for improving resilience to extreme and changing weather patterns. This is a study looking at a number of farms across 9 states over 3 to 5 years, from 2015 to 2019. So the researchers were looking at changes in soil health indicators such as active carbon or soil organic matter. Um, Over those 3 to 5 years, we did see increases in those soil health metrics. The thing to note, though, is that those changes were very small by each year. For example, in the researchers' data set, aggregate stability increased by only 1% per year on fields using cover crops than those that did not, and soil organic matter increased by only 1/10 of a percent more per year. So again, it's going to take time to build resilience in our operation. The other thing, in just terms of the biological processes, many of the farmers you work with, I'm sure, if you're a farmer yourself, know that it takes time to work out the kinks with adopting a new practice. And it's more likely that you will want to work out those kinks before you're faced with increasingly dramatic challenges. And this is, again, a bit of a recap of what we've been discussing already, but we already know that we need to make decisions about the future now because some of these decisions require rather long-lived investments. We know that farmers who are interested in climate smart practices, are interested in, again, moving to reduced tillage, no-till, but switching operations in that manner requires a fair bit of capital investment and subsequent planning, particularly when we see that crop machinery costs are increasing and that commodity prices are decreasing. So I want to move us to thinking about frameworks for the long-term decision making that I've been referencing. It's in our nature to make plans based on what we've done that have worked previously or on shorter term forecasts, what might happen today or tomorrow. However, using long-term climate data requires a shift in thinking. Again, we can't tell people what day in April it will rain or exactly how dry it will be in the summer of 2053. So it requires us to approach these problems with a new framework for decision making. One of those frameworks that we can use is called scenario planning. It makes assumptions about what the future is going to be and how your business environment may change in light of that future, and can be used to develop a plan for how to respond to those changes. It's the process of thinking through different scenarios and then planning what you'll decide to do if those circumstances come to light so that you can be more prepared for whatever happens. Your brain has already run through and prepared for various options, so you can be more comfortable when approaching that situation. So, some farmers we've met this summer who we interviewed about their use of long term data mentioned that they think of their operation in terms of thinking about their wet strategies and dry strategies for a particular year, which allowed them to pivot than if they weren't thinking about what strategies might be in their toolkit at a given period of time. The other thing we need to consider in terms of frameworks for long term decision making is ways to spread risk. So we know that production, financial, legal, marketing, and human risk all impact farm performance. We're really focused on how we can decrease those risks. Um, a number of organizations, including some that we partner with, have moved to this idea of whole farm planning for resilience, where again, you're thinking about risks across buckets beyond the purely economic or agronomic components of the farm. So this kind of process is outlined in a great resource by USDA. It's called Adaptation Resources for Agriculture. But the process that is used by a lot of these groups is getting farmers to think about their goals and what they can control. Then understanding climate impacts and using those climate impacts to think about the risk to each and every part of their operation based on those impacts because we know that every operation is unique and it's hard to make broad generalizations. We then work with farmers to develop a plan for strategies they might want to employ in the next year, in the next 5 to 10 years. And then, of course, it's an iterative process where we're going back and evaluating if these plans are working based on what we experience as conditions become more extreme. Another component of this planning process is thinking about ways to either reduce risk or spread resilience across multiple components of the farm. So, again, if we're thinking about farming practices and stewardship, we might employ reduced tillage or cover crops or all, more diverse rotations. If we're thinking about people, if we know that pests are increasing, which will require more scouting, perhaps a person on your farm is going to be trained in drone operation so that you require less people power. Or if you have a smaller farm, perhaps you're training your staff in what to look for. We know that community is a big part of building resilience, just in terms of talking to your neighbors about what your experience, bouncing ideas off of each other in terms of what can be done. There are ways to approach resilience in terms of your long term financial planning, in terms of goals that you want to move towards in the future. And then we know that technology can be a way to reduce risk and spread resilience as well through the use of precision agriculture technologies, for example, or increased irrigation. So, I wanted to walk us through our tool that we have created. It's called the Resilient Farm Planner. And this tool really aims to bring together some of these pieces that we've talked about with knowing what you need to do order to do long-term planning, knowing what pieces of information you need to conduct that process, and making planning a little bit easier, either for individual farmers themselves or for those having conversations about farm improvements as an advisor. Uh, I just want to give a brief background on how we arrived at this tool. So last year, with the help of our partners, we hosted a successful community action meeting where, similar to this webinar, we brought together groups of people from multiple areas of agriculture, ranging from soil water conservation districts to seed companies, and show them the same data that we showed you about projected changes to our future climate. We then participated in activities that allowed us to identify strategies that help build resilience to those uh, expected conditions based on what's available now in terms of policy and programming, or areas that we need to expand so that farmers can continue to build their resilience. This summer, with the help of our intern, we were able to conduct a number of interviews with farmers who, again, are quite aware of changing climate and weather patterns and ask them questions about what information is most useful to them in making decisions and how they like that information delivered. And then finally, we identified a number of strategies for building resilience. We did this by using research, by using resources that have been developed by the USDA and the USDA Climate Hubs, and having conversations with experts from within University of Minnesota Extension. So let's talk about the features before we go to our live demo. The Resilient Farm Planner features include localized climate information for different regions across the state based on your climate division. You can find information about a particular season, and within that season, you'll find a summary of impacts. So, talking about, again, changes for that particular region and what it might mean for those of us who are working in agriculture. We've included some maps in the tool so that you can identify changes and how they might impact your operation in your particular region or county, or if you're interested in looking at how those changes might impact you relative to the rest of the state. And then importantly, we've included a laundry list of strategies that people might be able to employ. Again, with the goal of fostering targeted investments and increasing adaptive capacity on individual farms. I wanted to talk just a little bit more about what strategies are in the tool. So we've really tried to have a range of strategies available. So those ranging from low cost, low infrastructure plans that are easy to develop and deploy within 6 months to a year, such as having a farm safety plan if you're going to be working in warmer and increasingly erratic conditions. We have strategies related to mid-season, mid-cost strategies such as introducing cover crops, working with residue, dealing with weeds in a drought or in a wet year. And then we have strategies relating to long-lived high investments, such as drainage or new equipment required for reduced tillage. So I'm going to stop sharing my screen for a moment and we will walk to the tool. So bear with me for just one moment. Okay, Lauren, are we seeing my screen?
Sorry, my mouse fell asleep. Yep, it looks good.
Okay, so this is where you'll find the tool on our website. If you click on resources, you'll then click on Resilient Farm Planner. I believe Lauren has dropped the link to this tool in the chat. Um, you'll then click on Launch the Planner, and then you'll click on Start to work through the planner. So you'll be encountered with a little bit of the information I've given you today about why we're focused on long-term planning and how you might appropriately use this data. You can then select a region of the state based on what county or the region that you worked on. So for example, I'm going to click on the Northwest Climate Division, which has Kittson, Roseau, Marshall, Polk, Mahnomen, Beck, Clay, Pennington, and Red Lake counties. Gives you a bit of an overview again of explaining how these shifts are occurring and how we can think of responding to shifts. You then can click on a season to find out more about expected changes. So for example, I'm going to take a look at summer. So it gives you an idea of what you might want to prepare for. It gives you a high-level summary of the changes we might expect to see, such as precipitation patterns in this part of the state, not changing a whole lot, but temperature shifting. Can look at the data to make comparisons across seasons if you're interested about how those changes in spring compared to summer or winter. If you're curious about the data, we have a number of FAQs that you can read. And excuse me, Once you're in this tool, you can then, let me refresh my page, apologies for that. You can then move on to strategies or climate maps. So let's take a look at climate maps. You might be interested, again, in how these changes are impacting your region relative to the rest of the state. So we have these neat scrolly maps that can help you visualize these changes, or perhaps you'll use them in conversations with your growers. So this map is looking at the spring average high temperature in terms of what we've experienced historically to a 2040 to 2059 timeline under very high emissions. So you can see how things change. We can see those warming temperatures creeping northwards over that future time period. And we have that for a number of variables. And then finally, we can click on management strategies. So again, we note that the northwest region of the state is not expected to become as dramatically wetter relative to other regions of the state, but farmers, based on their soil type, based on what they're growing, might be interested in building resilience for those conditions anyways. And again, we can click on different buckets of where you might build resilience in terms of soil health, or other variables. And if you're in someone who works across multiple areas of the state, you can go back and look at these seasonal differences for a number of different regions. So I have just a few more slides to wrap up our time together.
Looks like you gotta shrink it down again.
Okay, how is that?
Right now we see all your slides. There we go. That
Okay,
looks good.
great. So again, I just wanted to conclude our time together today with some additional resources. We will be hosting Risk to Resilience cohorts with partners this summer that is focused on taking farmers through this process of risk reduction and using long-term climate information in a cohort model. So if you're interested in doing that with your organization or a group of farmers you represent or work with, please reach out and let us know. We'd be happy to discuss offering this opportunity for different organizations. If you're interested in how you might take climate action in your personal life outside of what you do in agriculture, we have launched a new program called the Community Climate Leaders Program. That's again focused on what you can do as an individual to deal with the challenges associated with climate change. We have our climate adaptation specialist training, which is focused on teaching professionals how to appropriately use climate data in long-term planning efforts. This might be an opportunity you're interested in if you're in a planning role in agriculture. Uh, we are hosting our Midwest Climate Resilience Conference in Milwaukee in the fall of 2025. So if you're interested in connecting with professionals across the Midwest about their climate resilience efforts, consider attending. There's more information about that on our newsletter and on our website. And you can access all this information and additional online resources at climate.umn.edu. We do have a climate change impacts on Minnesota agriculture report that we made with several of our partners. That's available for you to read if you want a deeper depth dive into climate impacts across the state and how it relates to agriculture. We have a webinar that you can sign up for if you go to that link, and you'll get monthly updates about what MCAP is up to. And finally, we just would like to say thank you to the Minnesota Corn Research and Promotion Council for their support of this project and the creation of this tool. And if people have additional questions or contacts, they can contact me at black807@umn.edu. We have about 10 minutes left for questions, so I'm going to Let people ask questions. Again, you can use the Q&A feature. I'm going to stop sharing my screen and we will see if anything comes in. Has any farmer started using this tool? We will be, oh, let me see, answer live. I will answer this one live. Yes, that's a great question. So we will be trialing the use of this tool with farmers through those resilience cohorts. So we have shown various groups of individuals kind of the process of creating this tool, and we've had people work through different components of the tool. But with this launch, we'll have opportunities to gather feedback on how farmers are responding to this information and if there's additional information that they would like included in it. Okay, we have a question about strategies in the tool. Can they be applied to different row crops, specialty crops, etc.? Yes, the strategies are intentionally designed to take you to links where you can get more specific information. We're not giving rather specific information within the tool just because, again, there's so many factors that go into making a decision when working with individual farms. Um, with that being said, right now the strategies in the tool are predominantly focused on corn and soybeans, but we hope in the future to include strategies that might be appropriate for diversified farmers or vegetable farmers or animal agriculture. We are just not there yet, but we are working with those groups. Can you talk more about the climate adaptation specialist training? Curious about that. So again, this is the use of that climate tool that I was getting data from. Again, it's focused for people who are interested in specifically learning how to use the tool. You're learning about the nitty-gritty of that long-term climate data and its appropriate uses. So traditionally, we've worked with different organizations and agencies to host trainings that take roughly a day where participants are working through a number of activities related to that and having discussions about how to make decisions using this data with the inherent uncertainty that's associated with using different scenarios. If that's something you're interested in for your group or organization, you can find more information on your website and you can contact us directly if that's something you'd be interested in hosting. Do you have any resources or cost share programs that are available for implementing climate smart activities? Great question, and an important question. So in the tool, we refer to some tools or tools and resources that can help finance climate smart activities. One of those is the Minnesota Ag Water Quality Certification Program. That's unfortunately only available in the state of Minnesota, but we have contacts within that group. If you have more information about how specifically that program works, it's a cost share assistance program. Then we also have linked a tool out that allows you to go in and find a specific region of the country, and the tool is doing the work of pulling out that specific information of what funding programs might be available to you. That's through a soybean association. You'll find that in the Strategies Association, and I can link that in a moment as well. Um, but again, an important question, and I know it's a bit hard to plan for these activities given the uncertainty at the federal level right now. Is it expected that more corn and soybeans will be grown in Minnesota? The future is temps rise in Iowa and Illinois? It's a great question. I don't have the answer to that question, but what we have been able to find out by plugging crop models into these climate models is we see that the regions in which we traditionally have grown corn tend to decline by anywhere from 5 to 15%, depending on the emissions scenario you're looking at and the timeline. But we also see increases in more northern parts of the state where we haven't seen a ton of corn and soybean production previously. I think we'll wait and give folks one more moment to ask a burning question. And I'm not seeing any additional questions coming in. So I think with that, we will conclude our webinar. Again, thank you for your time and attending. And again, please don't hesitate to reach out if you have additional questions or comments. You can contact me again at black, like the color, 807 at umn.edu. Thank you, everybody, and have a good rest of your afternoon.